Today, we will be discussing safe work practices for handling some of the smallest materials in your lab, nanomaterials. Nanotechnology refers to a wide range of technologies that measure, manipulate, or incorporate materials and/or features on the nanoscale. What's the nanoscale? It's typically defined as 1 to 100 nanometers, and 1 nanometer is equal to 1/1000th of a meter. Obviously, we're talking small here. We should note there is currently no consensus on a definition of nanotechnology, but several emerging definitions typically contain the following elements: size, solid particulate substances, dimensionality, inclusion of aggregates and agglomerates of nanomaterials, and materials that are intentionally produced with novel properties.
Like many scientists, our lab worker Valentina is very interested in nanomaterials research, as the novel properties of nanomaterials can lead to new and exceptional applications such as different and desirable properties and refined and novel approaches. Just imagine what's out there for nanomaterials research. Working on the nanoscale can uncover different and desirable properties such as altered color, reactivity, electrical conductivity, and enhanced strength. And research at the nanoscale may also lead to refined and novel approaches in many industries, like targeted drug delivery in the pharmaceutical industry. Valentina has experience working with nanomaterials and will help us learn about the associated health and safety issues. Remember, the properties that make nanomaterials desirable can also change their potential hazards. For example, materials at the nanoscale can have altered uptake or absorption and distribution within the human body. This means that nanomaterials could be absorbed by the body faster, resulting in greater exposure. Also, nanomaterials may travel to internal organs that were not previously accessible to the larger scale of the same material. Research shows that the toxicological impact can be different between large and small ultrafine particles of the same material. In fact, experimental studies in animals for the same material have shown that the toxicity of ultrafine or nanoparticles is greater than that of the same mass of large particles. Valentina is cautious when reviewing hazard information sources such as material safety data sheets or MSDS. When using smaller amounts of nanomaterial, Valentina questions any health hazard information provided for bulk material because the listed hazards may or may not be the same. The bottom line? Before any work begins, you must thoroughly pre-plan and take appropriate protective measures when handling nanomaterials in the lab. Valentina takes part in the pre-planning process for her projects by assessing potential worker exposure to any nanomaterials that will be used. Valentina, her co-workers, and supervisor conduct qualitative exposure assessments to define various aspects of the project, including the tasks that may potentially expose workers to nanomaterials, the dustiness of the material, how it will be used, how much will be used, and the duration and frequency of the task. Once the pre-planning is finished, the key to safety is straightforward. Keep nanomaterials off your skin and out of your lungs and eyes. Valentina follows basic safe work practices to accomplish this goal. She uses ventilation to keep nanomaterials from becoming airborne. Ventilation systems capture and remove airborne nanomaterials before they are inhaled by workers. A fume hood is an excellent choice. For larger scale operations, use ventilated enclosures, local exhaust ventilation, or other types of ventilation. When needed, semi-quantitative assessments can be made using direct reading nanoparticle counters. These particle counters are good at evaluating the effectiveness of ventilation systems and can help show where improvement is needed. However, for larger scale operations, current research and industry practice recommend using a tight sealing respirator with a P100 filter in addition to disposable suits. And, before use of any respiratory protection, Valentina and others are medically evaluated and receive a fit test for the type of respirator that will be worn. Nanomaterials and nanotechnology have a lot to offer researchers looking for novel applications. But remember, the very qualities that make them desirable also present unique safety hazards.
Knowledge and training will help you stay safe when using nanomaterials. And with nanotechnology, any little investment in your safety can have huge benefits for your success.